Alright, I'm back. I get a glass of water. I'm all taken care of. Okay, so I did hit record, yeah? Okay. Fix the reset button. This reset button is wrong. Where is that? It's way up here in handle click. So if this is greater than 530, so I'm going to do that thing again that I did with paint. Oh, look how far we've come. Don't save that. I did want paint though. Alright, so where is this? So we want Y to be 530. That was right. And greater 500. 500. MX is less than 550 or 685. 685. Oh, so I gotta fix something because reset doesn't work twice. So what should I do about that? That would be is game over equals 0, flags placed, elapsed, game started. Randomize the grid. I'm trying too hard. I'm trying really hard to be clever. If is game over, handle click squares, flags placed, game started. Else okay, hit there, game over, restart, does not work. If is game over, just handle squares. Oh, I could just do this if is game over. Sorry. Return -1 or return 0. Is game over? Is game over? Okay, and not that. This pointer to that. Okay. Sorry, I'm not really explaining what I'm doing sometimes. So what I want to do here is I do want to pass this, but I want to pass it as an integer. And then we're going to dereference that. And you're going to tell me it's constant, but I don't care. I might as well just set that to -1. I'm going to fix this in a minute, but I want to get through this first. So what we're going to do is that just to get this done. Game over, restart. Oh, lucky. Game over, restart. Game over. All the timers stop. Restart. Oop. Oh, I see what happened. It counted the top bar in that calculation. So 500, because I didn't get the client width, you know. Sorry, not that wide. 450. 490. Oops. 495. A little too far. 475. Greater than 475. Less than 500. $475 to $550. I'm so close. And then we're almost done. Game over there. Game over there. I don't care if it goes out of the box a little bit. That doesn't bother me too much. I can answer this question. It's 40 tall. Okay. 475 plus 40 is 520 or 550. I swear we're right there. There are better ways to test your UI, but I apparently am not interested in those. Alright. Fix the reset button. Done. Make a difficulty menu in the amount of bombs proportional to the grid span. Okay, so this is what I was talking about where I said we'll get to this in a second. So what I'm going to do now, actually, officially, is we're going to start like doing proper stuff. So we're going to do type def struct, it's going to be anonymous, game data. What's going to be in our game data? We're going to have all of our stuff, right? So what is all of our stuff? We're going to have elapsed, game started, number to flag, flags placed, is game over. I'm basically just going to take all of this and put it in here and just start deleting stuff until it looks good. Okay, so I'm going to give this a variable name real quick just so we can visualize something. So my editor, CLion, will tell me actually how big my structs are. It'll tell me that my size is 40 and my alignment is 4. And the reason is the size of a float is 4 bytes, and an int is 4 bytes, and this is 4 bytes, and this is 4 bytes, and this is 4 bytes. So your alignment is how big your biggest entry in this struct is, and your size is how many of them are there. So there's 1, 2, 3, 4. So if I have right here, say, a char, something, or sorry, I spoiled the punchline, but char is 1. So this, if you hover over it, the size is 4, the alignment is 4, and the offset is 12. Because there's 3 elements before, 4, 8, 12, 16. This starts at the 12th thing and goes up to the 16th address. And then this, it says it's 1. Char is 1 byte. But it says +3 padding. Why is that? Well, padding is when, if you have a alignment of 4, and you put something in that's 1, it can't offset by exactly 1. It has to offset by its minimum viable alignment. So putting that in there, it means that just by putting this here, I have wasted an entire 4 bytes because that has to go there. So if I move this down, it's not going to fix it, but let's say that I had something, right, so I have all these, there's 4 of them. If I look at it now, I have 24, right? If I move this up 1, I'm at 28. How did I go up by 4? Char's only 1 byte. This one now has 3 padding in place just because of where it is. So that's something important that you should probably take away from C. If you get anything away from this at all, I think C++ is like this too, but if you take anything away from this video at all, be aware that the way that you organize your structs, like just literally the way that you type them, can influence how big they are. And I've heard somewhere that some compilers are smart and they will just be like, oh, and then they move things around. But other ones are cautious because you may have put them like that on purpose. So be aware of that. Just something to think about. So thankfully CLion will tell me that. I do not know if Visual Studio does that, and I do not know if like Vim does that or NeoVim or anything. I don't know if anything else does that because I don't use them. I use this. So I know that it does it in this. I don't know if it does it somewhere else. So just that's something to keep in mind. Now, instead of having everything just kind of all spread out, we've got a very primitive data structure, a struct if you will, called game data. So game data, we're going to initialize it in the main function, and all of those are number values, so I can initialize them all to 0, and I'm going to utilize that. Game data equals this. Everything in there is now 0. So instead of all of this stuff, we're just going to delete that, and we're going to replace the errors as they come. Flags placed is game over. Number to flag. Okay. Now I'm going to pass in a reference to data. So what does that do? We're going to come up here, and this is no longer going to be number to flag. This is going to be game data pointer data. So to get into that, we're going to do data and then point to that. We're going to reference that. We are going to be changing some things. So the rest of this method looks okay. Alright, I'm going to collapse this just to get it out of my way. Oh, and I should probably put squares in there too. So this is going to be even more interesting because if I put grid square pointer squares, I of course should probably define that after grid square is defined, but if I put that, this is a pointer. On my system, I'm on a 64-bit system, so that size is now 8. That has reshifted or recalibrated the entire alignment of my struct, so they're no longer 4 aligned. We went up by another 24 plus, yeah, we went up by 8 bytes just by introducing this because it has offset my my alignment. Let's just do this. It's game over 2. Right. So we're at 32, but if I go down 1, now we're at 40 because we went up 8. Because now this has padding on it. Or sorry, this has padding on it. Right. I hope that makes sense because that can that's really useful for stuff where you need to be small, like in embedded and in networking stuff. So I'm going to keep a reference to the squares as well. But what that means is that we're going to have to malloc squares. Handle click, flags placed, game started. So all of this stuff can be replaced with just game data pointer data. And how do I do that? data dot this. What was that? Data dot this is game over. Data dot started. What game started? Data dot squares. I'm gonna just copy data there, put it there, and put it there, and put it there, and there, and there. Okay, and we're going to do plus equals 1. Okay, this is not going to work for a long time, so buckle up. We just have to go through, because I'm not pointing to it, because it's right here, it's a local variable. I can actually just reference it with a dot now. So data, a handle click is now going to just be data. And then data dot is game over, handle click, data. Reference. If data dot game is started and not data dot is game over, and say data dot is elapsed. We're getting there. Data dot is game over. Data dot, I'm going to copy this and I'm going to paste it here. But everything should work now. Grid squares, randomize the grid, game data, okay. And I could fix that in a second, but I won't. Flood fill. Alright, here's the hoping. There it is. Zigzag, I guess segfault from handle click. I think I have an idea what happened. And it's because, like I said earlier, we have to malloc squares, and I didn't. So, popping that away. Bye-bye. Squares, yeah, all that stuff's broken now. Randomize the grid, we're just going to pass in data. Right. And go back up to this, and we're going to get rid of that. So that's going to break all those things. So, we're going to Alt-Enter, change all local squares to data squares. Okay. That was easy. Alright, so squares, change all local squares to data dot squares. Alright, so that fixes it. So then we just pop this off the back, and if we're going to reset the game, we don't have to realloc this thing. So what we can do instead is when we come up here and get the game data dot, oh, I do want to realloc it because I can set a different one. Sorry. We're going to do data dot squares equals malloc, yep, size of, what do I call it, grid square times row call or span. Grid span. Right? Okay. Try that again. Almost. Things are going to break for a little bit. And I tell you what, I'm going to come down here and do this again. I'm going to see what it is doing. nothing. So they're all... There's no bombs, there's no flags. Stupid. Alright, so data.toFlag equals 200. Alright, don't worry everybody, I figured it out. There we go. That looks more familiar. I don't know why this one's 3. It shouldn't show anything. But that's not supposed to be seen anyway, so that is fine with me if that's got a bug in it. Because it's a bug in forbidden knowledge. Game over. Restart. Okay, restart. Okay, restart. Alright, everything seems to be working. I got everything out into a game data thing. What we could do is come up here, right? Set difficulty. So set difficulty, I want to make the menu to like resize the thing. What we're going to do is we're going to have to pull all of these out and put them inside of game data. And I'll tell you why. So this is our pointer, that's 8. This. Oh, we might be in for some a treat, I think. So this screen height, we're gonna have to do something clever with that, I think. You know, anyway, these can stay. Grid spacing, row call is what needs to change. So we're gonna say int roll call grid row call so that I can get those both capped. Alright, I'm gonna be a little reckless with this. Padding is gonna stay padding. We're gonna keep that there. Row call. Let's get rid of row call. That's gonna break a lot of stuff. Okay, span. You can get rid of span. Screen width is going to be... Before I do any of that, I'm coming down here and I want to check to see if we have set window size. Okay, we do. So what we're going to do is we're going to set the window to initialize at some size. So default, oh my god, not default, define menu size or menu width. That will be 100. Define menu height 400. Yes, I'm sorry. Okay, so then we're going to come down to here. Menu width and menu height. Okay. It's going to break, but okay. That's interesting. So yeah. Menu width, maybe even not, maybe just menu height should be like 200. Yeah, okay. So then when you select a menu item, it's going to resize the window to the appropriate Minesweeper window. Alright, so all of these things that say grid row call, I'm going to just completely destroy this whole program. I want to separate this out into what we're going to call update game state, and we're going to do data pointer to data, which means we need a method up here called void update game state. Pass that in there. Game data pointer data, and then right here, CLion is great for this. Ta-da! Square bezel color. I'm going to promote all of these colors to static, I think. So let's go all the way up to the top, right up at the defines. Paste that up there. Is that going to compile? It did. Okay. Alright. I don't really feel any shame in that. So this... oh, let's get rid of that. And that. And I don't see anything else like that. Okay, right here. Okay. So that's back to normal. This still won't shut up. We're down here. What are you telling me about? Redundant parentheses again? Yeah. Okay, so update game state. Look at how small our main method got. That's crazy. It's a grid span. We don't know that yet. So we're going to have to keep this like that. Alright, so we're going to use this as our pivot point. So what we're going to do is if, or even better, I'm going to show you how to do this. If you don't know, now you know. I'm going to scroll all the way to the top again. Right around here, type def. You don't need that anymore, we're pretty well understood on that. Type def void star current state callback, and it's going to take game data pointer data. Okay. Don't actually think I need to name it, but what this means is now I have to go back down here underneath game data like that. So this is a callback. This is how you define a function pointer. So this will be one function pointer, and then this will be the other function pointer. Update void update update game update menu state game data pointer game data. Okay, and what we're gonna do is make this shit, you know what I want to do? Int pointer current state int pointer current state. So that means we're going to go right here, int current state, right, 0. I'm going to show you how to do this one thing anyway, and it's going to be current state. It's our pointer to current state, our current state's address. So what we could do is up here as like a global, or even we can define it here. We can say state current state callback current state array equals this, and we can set this to update menu state and update game state. I have to go all the way up top here to make sure that this also has an integer pointer. Okay, coming all the way down. State func. So now current state is 0. So if I take this, we're going to do state func of current state that. So if key pressed, is it? If key is key pressed, there it is key pressed space bar, space button, key space. I was gonna get it eventually. Current state, dereference, current state. Okay, if is key pressed. Sorry, that should be the if statement. Right, so just if we hit space, it will go to the other state. Right, so do nothing. Oh no. I forgot that we need to at least have a draw call in there, or begin drawing and end drawing. Right, so if I hit space, then it switches states. We're in a different state now. So I don't know which one of these is slower, but I don't care because this is a cool way to handle it. This is a state machine. Right. So if we hit space, current state +1, but also we're going to do all of this stuff. There. And then data is now like this. Come on. Okay. Alright, so data.squares. If data subsquares equals null pointer, here's null pointer. What the hell is happening? Null pointer is in C23. Right, anyway. 0. That's all null pointer is. If it's 0, then we're going to do this, malloc. So now, if we malloc this, we'll have a memory address in here, and it will not be equal to 0. Okay, let's see if this crashes. Right? Didn't crash. Very cool. Alright. So, look how small our main method got. That's crazy. So, begin drawing. Draw menu buttons. Right? And if is key pressed, space, do this. So, this is now inside of a different function. Right here, update gain state. Do I need clear background inside of begin drawing? I don't know if I need that in the middle of begin drawing. I haven't had a problem yet, so I think it's fine. Okay. Current state. If you hit escape, I want it to bring you back to the menu. But I'm getting ahead of myself because game data needs to be set there, and everything's set to 0. The current state equals 0, and then we start our game. Okay? You know what? We're in a working state right now, okay? Sort of. If I hit space right now, it will actually do all this stuff before we can play the game on this tiny ass little grid. but it's a little different, right? So I think this is as good a spot as any to pause this video and maybe cut it into a different video.